Assalamualaikum and hi to my respected lecturers and peers. I am Muhammad Shamil bin Shamsul Bahrain and I would like to share with all of you the title of my PSM project, Invisible Design of a Passive Lower Limb Exoskeleton for Prolonged Standing Tasks, supervised by Dr. Isa bin Halim. Just a short overview of Dr. Isa. He is a well-known researcher and expert in industrial ergonomics, occupational safety and health, as well as prolonged standing, and has published over 110 journals throughout his career. My previous background of study was a mechanical engineering diploma in automotive manufacturing design from Polytechnic Muazzam Shah. Now to start. Many industries require their employees to perform standing tasks in awkward positions. Prolonged standing tasks will eventually fatigue the operator and may lead to occupational injuries. The invention of a wearable chair has reduced musculoskeletal diseases known as MSDs inflicted by prolonged standing task employees significantly. Although it has yet to be widespread throughout the industries as factor has been overlooked, the psychological impacts of using a lower limb exoskeleton. The project structure is shown below, as each objective is answering to a particular problem statement and its methodology is based on the objective set. The first problem statement is psychological acceptance of users towards using existing lower limb exoskeletons is low due to its bulky design, and to combat that, we have to determine the user needs and design requirements of the invisible passive lower limb exoskeleton for prolonged standing tasks. Next, invisible design of passive lower limb exoskeleton for prolonged standing tasks appear to be scarce in the market and actual application across the industries. Therefore, we have to design and develop a medium fidelity prototype of an invisible lower limb exoskeleton to be used under users' clothes. Lastly, a user range of motion is limited by the design of existing prototype and commercial lower limb exoskeleton. So, we have to evaluate the usability and its effects on users' range of motion after the completion of our medium fidelity prototype. As you can see, the worker is standing on an assembly line for a full 8-hour shift with an hour break every day. Extended exposure to prolonged standing tasks can be detrimental and very likely to develop a musculoskeletal disease such as sleep disc, knee pain, and so on. Based on these objectives, we have been enabled to construct a project scope to study on the user application environment, prolonged standing tasks, common positions, and user criteria. After that, designing an invisible passive lower limb exoskeleton for prolonged standing tasks which can be worn under users' clothes. Once that is complete, we can develop the appropriate mechanism to be used to fulfill the invisible nature of a lower limb exoskeleton. Lastly, to evaluate the invisible passive lower limb exoskeleton for prolonged standing tasks in comfortability, range of motion, and user satisfaction. Guided by project scope, we can focus all the resources towards a few major points of research in our literature review. Firstly, MSDs associated to prolonged standing. Next, exoskeleton technology and its applications in industries. On top of that, psychological impacts of wearing an exoskeleton as well as emerging of invisible exoskeleton technology to gain user acceptance, and last but not least, the exoskeleton design and development process. These are the few journals amongst many more that has been most impactful towards the development of the project that I have cited in my project report. For the next chapter, as you know, the methods proposed will be essential to the fulfillment of our objective. Firstly, we have to identify the user base for prolonged standing tasks by interviews and collecting their use parameters by giving a verdict on an existing lower limb exoskeleton. Next, formulate a technical specification of project by determining factors of material, mechanism, degree of freedom, mobility constraints, and most importantly, its physical dimensions. Once that is determined, design the project from conceptual designs with ergonomic anthropometry consideration and mathematical calculations in mind. To proceed, fabricate a low-fidelity prototype for proof of concept. Finally, evaluation of the product from user testing and feedback supported with data cross-examination and system usability scales. From the literature study, we have identified that substanding and sitting is the most common position workers are exposed. Substand is a position slightly lower than normal standing height, normally to avoid low structures when on the job. To do so, the movement between the ankle and shin has to be supported to relieve stress from the calves and feet. As for sitting, the buttocks and thigh area has to be supported to relieve its stresses. In order to make it safe against moment forces, a support mechanism has to be implemented to negate the issue of falling backwards. The design that I have chosen for this POC is a combination between a soft exosuit and a solid support mechanism. For the substand position shown, a shin pad is worn by the user and is supported by the rear footrest. As for sitting position, a plunger rod design is adopted to support the thighs from the rear footrest. A moment support arm can be rotated from the front to the back prior to engaging sitting position. Shown here is a low-fidelity prototype to prove the mechanism concept. The subject in the photo is a 190 centimeter male weighing 80 kilograms. This prototype is not weight-bearing as cheaper materials are used for this initial prototype. The two positions have been taken and thigh support mechanism is optional based on the user's working application. These are three major assemblies to this design. On the left, the shin support with one strap to secure the calves and two straps to support it in substand position. Next to it is the largest assembly, which is the thigh support and female plunger with two straps holding it on the user. On the far right is the footrest assembly, which comprises itself of a moment support arm and the male plunger, which can be adjustable for different demographics and users. The video shown is demonstrating the process of wearing this low fidelity prototype. To conclude my presentation today, I would like to share the key findings from the proof of concept prototype. Firstly, the thigh support plungers are limiting the thigh movements. To improve that, a ball joint or pillow ball setup can be used at the ends to increase the user's range of motion. Next, the thigh support in contact with the user should be reduced in footprint as it interferes during walking. Lastly, another strap should be added to the thigh support assembly to hold on to the user's belt to prevent it from submarining. That's all from me. I'm excited to hear your comments in the upcoming Q&A sessions. Assalamualaikum and goodbye.